So what we're going to do now is we're going to look at exponential growth, and that means when you have an exponent and we want to graph this. So here's our equation, y equals 3x, and we want to graph this equation. So we're going to pick numbers for x and then figure out what y is. And if you look right here, we picked -3, -2, -1/2, 0, 1, 3/2, and 2. And every time we picked one of those, we got an answer. So we got our answer right here, 1/27, 1/9, a radical number, 1, 3, radical 27, and 9. So we have those ordered pairs. So our first order pair really is -3, 1, 27, which is a really small number. And the next one, we have a -2 and 1/9. And we have 0 and 1. And we have 1 and 3. And I'm not even doing the radicals, but I'll do the other numbers. So we have 2 and 9. So if we plot just these points, you look over here, they're on the graph. -3, 1/27 is really close to 0. -2, 1/9 is also really close to 0. 0, 1 is pretty simple. That one's that point. 1, 3 is right here. And then 2, 9. And if you notice, if we keep adding numbers, if I were to do the next number, 3, for example, you put 3 in, and 3 to the third power would be 27. And so this point would be 3, and it would be way up here somewhere at 27. So it's growing. So the line going from left to right is going up. So that's why it's called exponential growth. And so all you have to do is put numbers in for x and then get your y values and then go ahead and graph those. And the graph will go similar to what you see here. Now what we wanted to be able to do is also identify the domain. The domain is the x values. Well, the x values can be any number. You can put any number you want, so that's why it's all real. And then because the range is the y values, that means what numbers are the y values, and they're all above this line right here, which means they're all positive, and so our range is all positive answers. So now we're going to look at decay. Decay means, obviously, you think about decay means we're going down. So if we look at our type of graph, and we're going to do the exact same thing we just did. Here's our -3, our -2, our 0, our 1, and our 2. And the reason why I'm only picking those is because we have numbers that aren't radicals. We have 27, 9, 1, 1/3, and 1/9. So if we put that order pair in, we have a -3 and 27, -2 and 9, 0 and 1, 1 and 1/3, and 2 and 1/9. So there's our order pairs that we can graph, which they've done for you. A -3 and 27 is up here somewhere. -2 and 9 right there. 0, 1. 1 and 1/3 is very close to 0, and 2 and 1/9. And you see how it goes down. So now when the graph is going down, it's decaying. So it starts off really high, but it goes down low. So that's why it's called an exponential decay. And so we have our domain, our x values, which, let me go here, our x values, or you can use any of them. So that's why it's all real numbers. And then your range is still all positive numbers because it's still above the line. So our y values are all positive. And so that's how you determine the domain and range. And the graph is simply putting in any x value because it's all real numbers. And you see what you get when you get those answers.